Hello everyone, my name is Andreas and I am from Harokopio University of Athens. Today I'm gonna show you our research about the detection and mapping of seismic deformation induced by moderate earthquake using the C-band chart data and geophysical modeling. So, the aim of our study is to record the seismic deformation induced by a moderate seismic event, investigate the potential impact on local settlements due to the surface deformation, and the geophysical modeling. So our study area is located on Greece, especially on the frame that you can see on the map. The seismic event took place on 2 of December of 2012 with a magnitude of 4.5 Richters. For our processing, we have used SAR-SLC images of Sentinel-1 Copernicus satellites program. And we have used two images in ascending and two images on descending in order to generate wrapped interferograms and loss displacement maps. Here you can see the flowchart of our methodology. For our processing, we have used the software NVSARscape, and we have followed the basic steps in order to generate loss displacement maps in ascending and descending mode, and the displacement decomposition products like east-west and vertical displacement. Moreover, we have followed basic steps for the geophysical modeling using the Okada techniques in order to generate a fold with a slip distribution. So here there are our first results. We have on the left we have the wrapped interferogram in ascending mode, and on the right the wrapped interferogram for the descending mode. Here you can see the loss displacements. On the left we have in ascending, and on the right in the descending mode. The higher displacement was detected on the ascending mode, which is up to minus 6 centimeters. While on the descending we have a displacement up to minus 5 centimeters. Here we have the displacement decomposition products on vertical and east-west component. On the left, as you can see, it is the vertical displacement with a higher substance up to minus 6 centimeters. And for the east-west component we have movements up to 3 centimeters on each direction. With a blue color we can see the east movements, and with a red one the west. Here we have the Geospatial Intelligence applications in order to investigate the deformation on critical infrastructures like factories and solar panels, and a cross-section over the highway in order to investigate the deformation on the main road network. So here we have our first geophysical modeling results. On the observed, you see the loss displacement that we have generated from the in-cell processing. On the middle, you can see the moduli that have been generated from the Okada, and the residuals between the two layers. These results are in ascending mode, and as you can see here, they are in the descending mode. So here we have our final products for the geophysical modeling, and as you can see, we can see on the 3D projection the fault and the slip distribution. Moreover, we have a few information about the dip, strike and rake and slip of the fault. So finally, according to our research, it is possible to detect and record the seismic deformation induced by a moderate seismic event under the certain circumstances, such as the component of displacement direction, which in the interferometry shows greater sensitivity in vertical movements. The high temporal resolution of Sentinel-1 products is providing us high coherence between the images, that it is very helpful for our processing. And the low focal depth of earthquake it is the key for detection of the deformation. Further analysis comparing geodetic and geophysical data is required for investigate the accuracy of our result. Thank you very much for your attention and stay safe.